Okay, we are talking about linear inequalities in this section. We're going to be solving these just like regular equations, but because their greater than or less than sign is involved, we're going to get a range of answers. So anything greater than this point is okay, anything less than this point is okay. So what we need to start with, well, first of all, we're going to graph them, but we're going to make something called interval notation, which is really important to help us understand um, everything as we move into college algebra. This gets used quite a bit. So let's start by just graphing these inequalities. We read from left to right, and it's the same when we do an inequality. So obviously the closed end here is the less side. So when I'm reading one of these symbols, it's going left to right. So this is the less than, and we kind of just don't finish it. This is the greater than, and we don't finish it. So this is less than, this is greater than, we're going left to right. Another way to think of it is the alligator eats the bigger side. And although that's true, I think it's better off if you can read it this way. We're going left to right. This is less than, this is greater than. So if we're putting that on a number line here, we want this first one, x, to be less than or equal to 1. So sometimes in the past you may have seen this, you may have done this with a filled in circle meant I wanted that point as well. What we're going to use is a bracket. And what we're saying is that we want the x's that are less than or equal to 1. Well, wouldn't that be these? So we want to include 1, so we're going to put the bracket. Now we want the x's less than 5. Okay, we want all the x's less than 5, so our arrow is going this way, but we don't want 5. So if we don't want it, instead of an open circle, what we'll do is a parenthesis. And then lastly, we want the x's greater than -1. Okay, so we're going to do parenthesis, and this time we want the ones that are greater. So if we're doing our number line here, I want the x's less than or equal to -1. So that would be a bracket. Go on here. If we wanted greater than 2, we don't have an equal sign involved, so this can be parenthesis. And how about here? We want less than 3. Okay, more of the same. There's a lot of slides in this. I'm going to skip it. It's going to be exactly the same idea. Now, let's introduce this interval notation concept. And so let me show, that's not going to make a lot of sense. Let's do them and I'll show you. So if we put this first one on a number line, we want to include, we got a bracket from -3 on up. We want to be greater than or equal to -3. Well, we always read going left to right, so we're going to go up the number line, and we start wanting the numbers at -3, and it was included, so we gave it a bracket. Then we're going to go on forever. Well, if we go on forever, that's infinity, which is this symbol. And because we can never get to infinity, we always will use a parenthesis on that end. Now this next one is saying x is less than 2.5. So okay, we don't want to include 2.5, and we would draw it like this. Okay, well, as we're moving up the number line, we're immediately touching the area that we want. So this is called negative infinity on this side. And we would stop at 2.5, but we don't want it, so we gave a parenthesis. All right, x is less than or equal to -3.5. We've immediately, as we go left to right, we've immediately got contact here with the arrow at negative infinity. Remember, parenthesis, because you can't get there. And then we're going to stop at -3.5, and we want it, so we give it the bracket. Okay, I'd really recommend you try some of these on your own. I pause the video. Okay, so we want to make the graph if you need to. We want this. Now, we're going up the number line, so the first thing we get to that we want is 2, and there was no equal, so it's a parenthesis. We're going to go on forever, and you can never get there. Now, the second one here, we want to be less than or equal to, so this would be my picture. So in interval notation, I'm immediately touching stuff as I go left to right. Hit the arrow immediately. Now we stop at 1.5, negative 1.5 when we want it. And then lastly, 3/4 still just a number. We want to be greater than or equal to it, so it's a bracket. We're going to go on to infinity. Okay, these are all just repeating. I'm going to skip that. Here's the point of what this slide is saying. If I made a big scale like this, and suppose I was looking at x plus 3 is greater than 9. I'm going to put the x plus 3 on this side of the scale, the 9 on this side of the scale. Now look what happens here. If I took 3 kilograms off this side and 3 kilograms off this side, so first of all, this side is heavier. That's what it says. X plus 3 is greater than 9, so it's heavier. Well, if I take 3 off both of those, this side is still going to be heavier. It's still going to be exactly the same as it is now. And the same is true for subtraction or addition. Suppose I added 3 kilograms to this side and 3 kilograms to that side. It's going to be in exactly the same scale. It's not going to change a thing. And I'm not sure if we'll see it in this video. I think we do. I could divide away half of the stuff on this side and half of the stuff on this side, and I would still be in the same equilibrium. I could double the kilograms on one side, and as long as I did it on the other, it's still going to be in the same equilibrium. Now, there's one change to this, which I'll get to in a minute. One other thing we've got to watch out for, but what I'm saying is you can solve these just like you've always solved equations. And I'll show you the exception when we get to it. Okay, now they started with fractions, which is rather unfortunate, but all we would do, we can add a half to both sides. So when we solve that, we got to get our common denominators. We want n to be less than or equal to 9/8, and we want to put that in that interval notation, which they have not done, or I didn't show it. And we'd want a bracket. I don't know why to start an idea with fractions, but that's what's been done. Okay, so we're adding 3/4 to both sides, and we're just going to leave our inequality sign exactly the same. Now, because it's fractions, we got to be careful here. Oops. I'm going to turn that into 2/12. Remember, we're going to get a common denominator. If you do it to the bottom, you got to do it to the top. So I want p to be greater than or equal to 11/12. So on my number line, I want 11/12, and I'm going up. So in interval notation, it's supposed to be an infinity, I would have that. Yeah, again, I don't know why we're starting with fractions. So we're adding 1/3 to both sides. So you got to get a common denominator. I'm going to make that common denominator 12. I can turn both of these into 12. Well, one of them already is. Multiply by 4 on the top and the bottom. Okay, so I get 11/12. So r is less than or equal to 11/12. So interval notation, I'm instantly happy. I'm hitting the arrow at negative infinity. I'm going to stop at 11/12. It's because I'm going up the number line and then I stop. Now, this is saying that we don't change anything for multiplication and division, which I've already kind of illustrated to you. So there's going to be a trick, but I'm going to save that for last. So we're dividing both sides by 7. We get y is less than 6. Okay, everything there stays the same. Yeah, there's no inequality there. Hold on. Okay, so we're going to just divide both sides by 12. Works just like a normal equation. D is less than or equal to 5. So in interval notation, I'm not going to do the number line this time. Can you start to see that that is what we'd get? We want all the numbers less than or equal to 5, and that's the interval notation. Okay, same thing. Oh, no, we're ready. Okay, so what did I have here? Yeah, I'm going to just show you with negative 10a is greater than 50. Okay, we're going to leave the equal out of it for a second. Now do you see this is what this is saying? This side is heavier. Okay? Now if I were to divide away the negative, what this is saying is I'm going to divide away the opposite. So if I divide away the opposite, hold on, I got to pause this for just 1 second. Okay, sorry, I'm back and I can't save my picture, so I got to do this again. Okay, so we're saying negative 10a is greater than 50. Now, I'm going to start by let's just divide the 10. I'm going to leave the negative behind just for the sake of illustration here for a second. And you see that I would have that. I've divided both sides by 10. Now this is saying negative a is greater than 5. Okay, so it's saying negative a is greater, heavier than 5. Okay. Now, I don't want negative a. I want the opposite of that. So if negative a is heavier than 5, isn't a going to have to be less than 5? Negative 5? Do you see what I'm saying? If this is the opposite, then it's going to have to flip the inequality sign. I want the opposite of what I've written here. Okay, well the opposite is a is less than negative 5. It can't stay the same. I couldn't change this to suddenly have a and negative 5 there. It wouldn't stay the same. It can't be that negative a is heavier and so is a. That wouldn't make any sense. And so another way of thinking of this is, in math language, negative means opposite. So if I were to ask you, what is the opposite of the white dog? Well, it would have to be the black cat. You have to change the opposite of everything involved. Well, that's the same here. We can't leave, we have to change everything, the opposite of absolutely everything. And what I'm getting at, if all of this illustration doesn't make sense, if you have to divide by a negative, it means you're taking the opposite and you're going to have to change the direction of the inequality sign. So because I divided, or if you multiply across an inequality by a negative, it involves the opposite and you have to change the direction of the inequality. So now we have a is greater or less than or equal to negative 5. We put that in interval notation and we get this. Okay, so we're dividing both sides here by a negative 8, which I have to remember is going to flip my inequality sign. And now we have q is greater than negative 4. And so in interval notation, I would have that. Okay, same here. We're dividing by a negative 7 on both sides. So r is now greater than or equal to 10. Interval notation, you would have that. Okay. Now, I don't know what we've got left and how important this is going to be, but this is true. So sometimes we're going to be reading them the wrong direction. Like, I like it to go left to right, but suppose what we're interested in is the other way. Well, we can still read this. It's still the same thing to say x is heavier than a. Well, a can be less than x. It's the same. Okay, let me see where we're going with this here. I don't know how much is left. Okay, almost done. All right, so here, it's written on the wrong side. This isn't the way we've been going so far, but it doesn't change anything. We're just going to divide both sides by 4/5. Now, we've got fractions again. I wish they wouldn't have done that. If you divide by 4/5, you keep the top, change it to multiplication, and divide by, and flip the other one. So 4 and 20 can reduce to 5. I get negative 25. Now be careful here. We have a negative involved, but we did not divide by a negative. We divided by a positive, so this is fine. Now, this says negative 25 is less than u. And that gives me some trouble. Like, you can read it that way. But I like to just go ahead and turn it around so it's the same way that we have been reading it. And change it back. So, okay, u is greater than negative 25. Well, what would that mean? They probably already did it for us. U is greater than negative 25. That would be this. Now, I didn't change anything. I just wrote it because I like the U to be on the left. Okay, so we're dividing both sides by 3/8. Now, that is not a negative, so it'll be fine. Now, I'm going to change it from division, and turn it into multiplication. Keep, change, flip. Okay, that gets me 8. This gets me 64. So I've got 64 is less than or equal to m. But so you don't mess this up, I really recommend you flip it around. We like to have the m on this side. You see, that's the same thing. This is saying 64 is less than or equal to m. I want m is greater than or equal to 64. Same thing. And so in interval notation, you would have this. All right, there's a negative involved, but it is not what we're dividing. We're dividing by 4/3. So I'm going to have negative 24. Keep, change it from division to multiplication. It's going to be a 6. So I've got a negative 18 is less than n. Now, this has a negative, but I didn't divide by it, so I'm fine. You don't have to do this if you read it right, but I like to switch it around so I don't mess up. I didn't want negative 18, so I give it a parenthesis. Okay, so now we are going to multiply across by a negative, but that involves the opposite again. So we're going to have to flip the inequality sign here. Multiply both sides by -2, okay. So that flipped my inequality sign, and now I've got t is less than or equal to -16. There's my interval notation. Okay, I'm multiplying both sides by a negative. So that is going to flip the inequality sign around. I don't know, 15 times 12, so I'm grabbing my calculator. Okay, so -180. And again, I flipped my inequality. So this is, because of the equal involved, I got a bracket. Okay, I'm multiplying both sides by -4. So that's going to flip the inequality sign. And two negatives make a positive. So I want to use less than or equal to 64, and that would give me that. Okay, we've got another section on this where they'll get a little bit harder, but that's a good introduction, that it's okay to add or subtract or multiply or divide across an inequality. It works like a regular equation. The only time is if you divide by a negative or multiply by a negative, you're taking the opposite, and it requires you to also take the opposite of the inequality sign.